So I'm sure you all can see my screen, right? Okay, thank you. All right, before we start writing the code, let's have some foreground and background to writing Cairo smart contracts on Starknet. So I'll be reading through. One of the key applications of the Cairo language is writing smart contracts for the Starknet network. Starknet is a permissionless, decentralized network that leverages zk technology for scalability. As a layer 2 scalability solution for Ethereum, Starknet aims to provide fast, secure, and low transaction costs. Starknet contracts are programs specifically designed to run within the Starknet OS. The Starknet OS is a Cairo program itself, which means that any operation executed by the Starknet OS can be proven and succinctly verified. Smart contracts can access Starknet's persistent state through the OS, enabling them to read or modify variables in Starknet state, communicate with other contracts, and interact seamlessly with the underlying layer 1. To start writing your Cairo smart contract, you need to have installed Scap. So to even start writing anything Cairo, I'm sure you should have installed Scap and get your installation ready. So the difference after installing Scap with your Cairo program and your Cairo smart contract is that you add this flag, and this dependency. All right, so Scab facilitates smart contract development for Starknet. To enable this feature, you need to make some configurations in your scab.toml file. First, after installing and creating a new Scab project, so Scab new, whatever, in your scab.toml file, you are to add this Starknet flag, this Starknet dependency to your list of dependencies, if you have any, and add this flag. So next, enable the Starknet contract compilation of the package by adding a target.starknet contract section. By default, this target will build a Sierra contract class file, which can be deployed on Starknet. So remember the first class we had, I explained Sierra to us. So who can quickly refresh our memory on as to what Sierra is?
Can I talk?
Yes, you can.
Okay, so Sarah is more like the language Cairo gets compiled to. It's like the subset of the, is it the Cairo VSM or something? I can't remember before. But it's the compiled version of what Cairo gets compiled to on the
Hmm.
lower level.
Okay. Does anyone else want to try? Does anyone
Good
else?
evening. Can you hear me?
Yes, can hear
Okay.
you.
I think Sierra is the language that Cairo is compiled to ensure that it does not panic when it is in production or when it is deployed as a smart contract. Like it's like a middle point between the Cairo language and then the Cairo assembly language.
Okay, cool. But is Sierra a language?
I think it's like a stream of like commands because when I checked the Sierra file, I was just seeing bytecodes, something like bytecodes, hex, sha.
Okay. Okay, you both are correct. So Sierra is the compiler that compiles it from Cairo to Kazim, which is Cairo assembly language. All right. So if you omit to specify the target, your package will compile but will not produce an output that you can use with Starknet. Below is the minimal scarp.toml file required to compile a crate containing Starknet contracts. So the normal um, package, the name of your project, the version of the project, then the dependency flag. Because this is a Starknet smart contract, you need to add the Starknet flag as a dependency, the Starknet dependency, and the version of Starknet that you are working with. Also, because you want it to compile, you want Sierra, you want it to compile to Sierra code, you have to add this. So remember, was it you guys? Okay, I don't think it's I don't think it's you guys. It's see, I would go over it again when we instantiate a new project. All right. So this is setting up your file, your project to accept to start writing smart contracts that will be accepted by Starknet. So this is a general introduction of smart contracts that we all know. This is what you've been doing for the past 4 months. So you should know what smart contracts are. If you don't know what smart contracts are by this time, I don't know. I don't know what you did with your 4 months here. All right. Cairo programs and Starknet contracts. What is the difference? Who can tell me the difference between Cairo programs and Starknet contracts? You can just unmute your mic and speak. What is the difference between Cairo programs and Starknet contracts? Yeah, go ahead.
Okay, I think difference between Cairo program and Starknet program is Starknet smart contract is designed to only run on Starknet OS, while Cairo program can function as every other regular program and can be run on any other distance as long as you're using the Cairo VM.
Okay, thank you very much, Abraham. All right, so that's the difference. All right, so and then once you're writing a Cairo program, for any Cairo program to be executed, there needs to be a main function for the Cairo program to get executed, just like writing Rust or what program needs a main? Is it C? It's C, right? It's C programming language that needs a main function to execute.
And Java.
And Java, okay, cool. So they need a main function for any other functions to be executed in the program. Yes, so once you're writing a Cairo program, it will require a main function. But once you're writing a Cairo Starknet smart contract, you do not need a main function to implement, execute those the file. It's a different ball game altogether. So main is only found in Cairo programs. Anatomy of a simple smart contract. So this is a smart contract, and it's a storage smart contract. Now, okay, I think let me just read this before I do my explanations. This is a contract. You can see the flag, Starknet interface. It has a trait of high simple storage and a generic type. And it has two functions. Or what do you call this? Without the implementations, what are they called? When
Interface.
you, what?
Interface.
Okay, cool.
Interface. Yeah.
Yeah, but I'm referring to the function without the implementation. Once you see a function like this, right, without the implementation, what is it called?
An interface.
Func-
It's called an interface.
function signature.
Who said that?
Function signature.
Okay, who said it's an interface?
I did.
Okay. But do you know what interfaces are?
Yes, I do. After I heard his response, I figured I was wrong.
Why? Why do you think you are wrong?
Because you said function like the declaration without implementation. The interface has to be like like everything put together. So when everything is put together in that trait,
Okay.
that's what makes it an interface.
Yeah, that's awesome that you figured it out. Nice, nice. Yeah, so this is the function signature because it doesn't have the implementation, but it carries the entire signature of that function. And they are both wrapped up in this trait. So seeing something like this, you should understand that this is referring to an interface, right? Here, you have the flag, Starknet contract. And in this flag, you have a mode called simple storage. In this simple storage, you have another flag called storage. Yes, you can ask your question. Was someone trying to ask a question? All right. So you have a mode, simple storage. You need another flag called storage. And under this flag, we have a struct called storage. And this storage has a variable called stored data. and stored data is a uint 128. Outside, you have another flag called ABI embed. ABI embed has an implementation called simple storage of super high simple storage. So this implementation means it is implementing this trait called high simple storage, calling the first item set and the implementation for set, and get with the implementation for get. So this is a very, very simple smart contract. All right. What is this contract? Contracts are defined by encapsulating state and logic within a module annotated with the Starknet contract attribute. The state is defined within the storage struct and it's always initialized empty. Here, our struct contains a single field called stored data of type uint 128, indicating that our contract can store any number between 0 and 2 raised to power 128 minus 1. The logic is defined by functions that interact with the state. Here, our contract defines and publicly exposes the functions set and get that can be used to modify or retrieve the value of the stored variable. You can think of it as a single slot in a database that you can query and modify by calling functions of the code that manages the database. So, hope we all understand the, the use of structs in your smart contract. I think let me start from there. So what is struct, guys?
I feel it's the same use case for Solidity. Just gives you like a structure for your
A structure,
yeah, like a
a
structure for
structure
your
for,
data types.
okay, structure for your data type.
Mhm.
Is that all?
Yeah, just gives you like a logic for implementation. You can also use it in traits when you want to um work on traits for your contract. So I just see it as same thing, just gives you like a structure. Let's say you want to implement like a book this thing. So you just need like a structure to put in the data for the book that the person bought, the person's name. So for each person that comes to your bookshop, you have like a structure that collects their data. Then you can use it in your trade because I saw them using that in trade in the book.
Okay. Does anyone else want to explain to me what struct is? Guys, you've been writing this for the past 4 months or 3 months. And some of you have been writing it way before you came here. So what
Can
is
I
struct?
can I come in?
Come in, please.
Okay. So basically, something similar to struct is the way we have objects in JavaScript. So struct in Solidity, for instance, is just a in Cairo is a generic type actually. So it's used to group some data that's related. So to group some data that are related, we make use of struct.
Okay. Is that
Yeah.
all? Like, is that all? So after grouping this data, what happens? Was
Yeah,
any
we also use it actually. We use it to store data in a kind of key value pair.
yes. So where is the data stored?
The data actually is stored is attached to the keys.
Okay, nice. Okay. Uh so struct is, according to you guys, is a structure for data types. It's a structure for to arrange data types that are similar, or to arrange items that are similar, or refer to a particular field. But what is the use of struct aside just arrangement of data? Aside it being a complex data types that is formed by other um, data types, what happens to a struct? What happens to the information in the struct once that smart contract is deployed? What does the struct do? Okay, so most of us don't really bother. We don't really care about it. We just want to write our smart contract and deploy to the blockchain. Yeah, we are not really bothered about that, right? Cool. But you should understand that this contract you are writing is going to be deployed. And what executes smart contracts? Let's make it interactive. This is something, these are things you know. Don't feel scared or feel like I'm going to swallow you. These are things you should know by now. So just say it. What executes smart contracts?
Uh, the compiler, EVM, EVM.
The EVM.
Mm. That's
Okay.
for
Yeah.
Solidity. Yeah.
Yeah. So the EVM executes the smart contract. So that means, what does that mean? That means the byte code, right, that the EVM understands for that smart contract is stored there, right?
Yes.
Yes.
Okay, cool. Now we have struct. And you said struct is to give structure, right? So once this structure has been given, once these inputs are entered, what happens next? Where does this input go to? What happens once this structure is given? It gets stored. Oh boy. So you have a struct. You want to get a structure for something. And okay, it takes in different types of data. And you want, when this function that executes this struct is called, it will take this, and this from this person, right? Then pass it as the values to the various parameters in the struct, right? So once these values now are passed, maybe age, name, and stuff is passed, what happens to these values?
Yes. To the state.
Thank you. They get stored to the state, right?
Yes.
Cool. They get stored to the state. That means the struct doesn't just give you the structure for your to write your implementation in your smart contract. It doesn't just stop there. Once these values are instantiated, initiated, or whatever you want to executed or implemented, or whatever you want to use, in English you want to use, once there are values, these values will automatically get stored to state. And getting stored to state means there is a slot. Have you guys done something called slot packing? Or have you tried to build a smart contract and then you see storage too deep or something too deep, stack too deep error?
That's a deep, yeah. Mhm.
Yes.
Don't you know that it's the struct that is giving you that error? You're getting that error from something from your struct. Or you didn't research to understand it properly. And that is why in arranging your struct, you have to arrange your struct properly. If you're calling age and you're using units 256, that is not logical because there's nobody that lives up to the number, the last number in unit 256. So anytime you're instantiating age, it is proper for you to initiate it as a unit 8, right? What is the last value in a unit 8? You have the analogy that someone will live to that age, or at most that age, or a unit 16, depending. Unit 16 is even very large. So say unit 8. Then maybe something else. You have to allocate spaces according to that particular thing. Why? Because you have to consider the machine. You have to consider the slots, the space in memory where this information you are storing is going to stay. Is going to A slot stores one variable, and a slot only has the space to store up to 32 bits. And if it is not full, the next item in your struct is supposed to take up it's supposed to take up that space. So if from the beginning you are assigning age to be unit 256, that is already 32 bits. Its age is already taking up a whole slot in the memory. And then the next item, you put 256 unit 16 and stuff. It will take up, in the way it will save in the memory, you know that that's the way you wrote it in your struct is the same way it will get executed, right? One by one. It is not smart enough to look through it and gather all the unit 8s in one place, to put them in one slot to save space, and then move all the unit 16s or whatever, or join unit 8, unit 16, unit this to form the 32 bits and save them in one of the slots. I want you to understand what is going on behind the scene when you are creating a struct. So once you say, when you say you are creating a structure, yes, it is also for implementation and also for storing these values to state. And once you're storing these values to state, you should remember that it is going to be stored in a VM. There is an allocated memory space for these values to be stored. And in this allocated space, there is like a divide. It is divided into slots. That's what we call slot packing, right? It is divided into slots, and each of these values or information are stored in each of these slots. So if you have a unit 8, you have a unit 16 in your struct, you have to rearrange it. So you have your unit 8 first, unit 16 next, and stuff like that, so that the first 2 or 3 variables should form 32 bits. The 3 of them will be in one slot. And then if there is a unit 256, that unit 256 variable should be towards the end of your struct. So to stop that stack too deep errors you get, you have to rearrange the order of your structs so that you can conserve space. So why am I telling you, why am I asking you this and telling you this? I want you guys to really understand, go back and reflect and research, understand what is actually going on behind the scene. Because in Cairo, it is more like you are almost closer to the machine than in Solidity that just gives you, has just abstracted almost everything for you. Okay? But you understand where I'm going to, and do you now understand what happens at the end if they struct the full life cycle of data in a struct? Do you get now?
Yes,
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 I do.
Okay.
yes.
So Victoria,
Yes, ma.
yeah, so I want you to understand it well. You know you're a public speaker. Don't go and fall my hand, babe. All right. Let's come back here. So let me take this again so you get what I'm trying to say. The state is defined within the storage struct and is always initialized empty. Here, our struct contains a single field called stored data of type uint128, indicating that our contract can store any number between 0 and 2 raised to power 128 minus 1. So that automatically means if you are storing any number higher than that, there's supposed to be an error, right? The compiler is supposed to throw an error because you are going overboard. The logic is defined by functions that interact with the states. Here, our contract defines and publicly exposes the function set and get that can be used to modify or retrieve the value of the stored variable. You can think of it as a single slot in a database that you can query and modify by calling functions of the code that manages the database. So after my explanation of the struct and the slot, do you now, to some point, understand what this part is actually talking about? Talking about the slots, the storage, and stuff.
Yes, yes.
Yeah, it makes sense to me now.
Okay, cool, cool, cool. What about you, Benjamin, Abraham, Kemi, the rest guys in the class, in the call?
Yeah, yeah, get it better now.
Benjamin, do you get it?
Yeah, yes, ma'am.
Yes, I understand what you've been explaining.
Okay, cool, cool, cool. All right, so the interface. Sorry, guys, if I'm slow. We're supposed to start writing code, but I really want us to understand what we are doing properly. So you don't just write mediocre code just because you know Cairo syntax, but you write code based on you understand what the VM is. You know it's a CPU, a virtual CPU, and you know it uses the same machine language, and that is why the compiler is doing the work, and then it's compiled down to machine code and it is stored there, and it has a space and it's allocated space to every item in the smart contract. Every variable in the smart contract are stored in those slots that have been allocated. So when you are writing your code, you will not just write anyhow code just to make sure it is working and stuff. You will write code understanding economics, at least to some little part, understanding the computer, understanding the VM, and the best practices for writing the code. Please, that is why I'm really taking my time to explain this to you. So in case you feel it's boring, I'm sorry about that. I just want you guys to understand the background, the the back end of things before you start writing your code properly. All right. So interfaces. Okay. Interfaces represent the blueprint of the contract. They define the functions that the contract exposes to the outside world. In Cairo, they are defined by annotating a trait. Guys, please give me a minute. Okay, guys, please just give me 2 minutes. I just want to pick up a delivery outside. Can you hear me?
Yes, yes.
Okay,
Yes,
thank
ma'am.
you. Okay, sorry about that. So sorry about that. I'm back. Okay. Hope you can see my screen.
Yes.
Okay. So I was talking about interfaces. Interfaces represent the blueprint of the contract. They define the functions that the contract exposes to the outside world. So we all know what interface is. All contract interfaces use a generic type for the self parameter representing the contract state. We choose to name this generic parameter T contract state in our interface, but this is not enforced and any name can be chosen. In our interface, note the generic type T contract state of the self argument, which is passed by reference to the set function. Seeing the self argument, okay, Note the generic type T contrast state of the self-argument, which is passed by reference to the self-set function. This is the generic type. What does this mean? It means this is a contract. You are referring to the state, the contract state. That means the state of this particular smart contract. This, whatever is inside here, must be giving you values or giving you access to the state of this current contract wherever this interface will be called. So that is what this means. Now, it is saying here that it is passed to self as a reference. Now, in this, once you are setting is a right function. Why is it a right function? It is a right function because you are changing the states. Whatever you pass in here is going to update the state from what the value of the current state is, or update the state, meaning the state has not been initialized with anything yet. It is empty, and then whatever you set here will automatically be sent to state. So it is a right function. That is why it takes a reference. It is referencing this contract state. It is referencing the contract state. So anytime you see this reference, remember that we are referring to a right function. We are referring to something that is going to change the state of our contract. And when you see just self, the get function, it means it is giving you a snapshot of the current state of your contract. So you are just reading. You are not updating or writing to or instantiating a new destin. You're just reading. So for reading, it's just referring to self. But for writing, you have to reference the self and make the updates, make the change before it will get reflected. So this self is just the snapshot of the current state. It's just returning the current information in the state of this smart contract, while this returns the current information of the state smart contract and gives you the ability to update that information in the state. Okay, I just hope we are understanding this. So where was I? Okay, here. Seeing the self-argument passed in a contract function tells us that this function can access the state of the contract. The ref modifier implies that self may be modified, meaning that the storage variables of the contract may be modified inside the set function. On the other hand, the get function takes a snapshot of T contract state, which immediately tells us that it does not modify the states. And indeed, the compiler will complain if we try to modify storage inside the get function. So by leveraging the create and implementation mechanism from Cairo, we can make sure that the actual implementation of the contract matches its interface. So we all understand what is going on here, right?
Yes.
Okay, cool. Is it just Emmanuel that is following?
No, ma.
Okay. Benjamin,
I'm here.
so do you
I
understand
have a
what's going on?
Yes, I do.
Okay, Daniel.
yeah, I have a question.
Okay, cool.
Okay, from the definition of interface, you said it declares our function that we want the outside world to see from the contract.
Yes.
So if let's say we have a smart contract and we are writing a private function, if we don't declare it in the interface, will this still work as it should, or we
If you
have to
don't,
declare it a private function?
the private function,
Yes, ma'am.
the private function is private to that contract alone. Even if the contract is inherited, the children cannot even inherit private function. It is only within that function, that contract, sorry. So you cannot add a private function to an interface.
Okay, okay.
Yeah. Because interface is actually giving you the concept of inheritance, but controlled inheritance, where you inherit just what you want, just what you need, right?
All right, thank you.
Not the entirety. Yeah. You're welcome. Daniel Joseph. Okay, Victoria, ask your question.
Okay, so is it like in Cairo, does the same public, external, and private also apply for interface? Because for
Yeah.
validity, you have to do external for the other contract to be able to see.
Yes. As long as it's
Mm,
in the interface, right? It has to be external. It's
mm,
the same concept of smart contracts everywhere. The only difference is
mm,
that because of the language, this language is more closer than Solidity, that is more high level. So it's just the language syntax that would change, but it's the same
okay.
background knowledge of a smart contracts. It applies
Mm,
everywhere. Yeah,
that makes sense. Thank you.
you're welcome. Daniel Joseph. Is Daniel Joseph in this class?
Yes, I am. I'm in a noisy place, that's why.
Oh, if you're in a noisy place, can you hear me?
Yes, I'm using my earpiece.
Oh, okay.
Yeah. Let's go back.
Kemi, Kemi.
Yes, ma'am. Yeah.
So do you understand?
Yes, ma'am, I do. Thank you so much.
Okay. Emmanuel Okeke. Okay, what about the ladies, Mary and IJ? Are you guys on the call? I don't really know everyone by name. Nofisat Abiodun. Nefisat Abiodun. Are you with us? Okay, at least most of us here understand what is going on. So yeah, I'll proceed. Um, Victoria. So here, when you are implementing the interfaces, you have to add this flag. Before, it was external flag that was here, but it has been changed to ABI embed, blah blah blah. So what does this do? It makes sure that every function found inside this implementation is made external. That's what it does. So users can access it. Okay, so let's proceed so we can start writing code. It's almost 5. Oh, let me take this. Public functions defined in an implementation block. In the context of Starknet, a public function is a function that is exposed to the outside world. A public function can be called by anyone, either from outside a contract or from within the contract itself. In the example above, set and get are public functions. What we call an external function is a public function that can be directly invoked through a Starknet transaction, and that can mutate the state of the contract. Set is an external function because it can be called by anyone and it can mutate the state. That means change the state of the contract. A view function is a public function that is typically read-only and cannot mutate the state of the contract. However, this limitation is only enforced by the compiler and not by Starknet itself. So we'll discuss the implications of this in a later section. Get is a view function. Set is an external function. That means it is public and has the ability to change states, change the state of the smart contract. Now, okay. Since the contract interface is defined as this, in order to match the interface, the public functions of the contract must be defined in an implementation of this trait, which allows us to make sure that the implementation of the contract matches its interface. So what this means is that in this implementation block here, any function you pass in here must have been, the function signature must have been called in the traits. If you try passing in any function here that wasn't specified in the trait, it is not going to compile. It will return an error. If you have 3 functions here, you have function set, function get, and you have function update, and you only write function set and function get in this implementation, your code will not compile because everything in this trait, this is an implementation of this trait, so it has to execute, implement every function found in this trait. Okay. However, simply defining the functions in an implementation block is not enough. The implementation block must be annotated with the ABI embed v0 attribute. This attribute exposes the functions defined in this implementation to the outside world. Forget to add it, and your functions will not be callable from the outside. All functions defined in a block marked as this ABI embed are consequently public functions. Because the simple storage contract is defined as a module, we need to access the interface defined in the parent module. We can either bring it to the current scope with the use keyword or refer to it directly using super. So this is what it means. When we define the trait, if you can see in this contract, this trait is outside this module. So to be able to access this trait, you have to import it into this module. And to import it into the module, you can either use the use keyword or use the super flag. Super, then double colon, and then call the name of the trait. Why? Because it is just an immediate parent. It is in the same file. So you can use super to call it. and you can use the use keyword to call it. And whatever you save it at the end, you just, when you say implement simple storage of whatever is the last item you saved it here, you just call it. You don't need to put super with a colon any longer. So that is what that part is trying to explain. When writing implementation of an interface, the self parameter in the trait method must be of type contract state. Please take note and understand this thing clearly. Don't confuse it. When writing the implementation of an interface, so this is not referring to the trait now. It is referring to the implement parts in the module when you are implementing that trait. The self parameter in the trait method must be of type contract state. Remember, in the trait, you wrote it as T contract state, right?
Yeah.
Yes.
Yes.
So you wrote it as T contract state. Now, in the implementation, you remove the T. You are now implementing it. It is no longer generic. You are now implementing it. So you are removing the T from it and just calling the contract state. That is what this place is talking about. So the contract state type is generated by the compiler and gives access to the storage variables defined in the storage struct. Additionally, contract state gives us the ability to emit events. The name contract state is not surprising, as it's a representation of the contract state, which is what we think of self in the contract interface trait, when self is a snapshot of the contract state. Only read access is allowed, and emitting events is not possible. So you understand what this place is talking about. So when we are when we are okay, here. Additionally, contract state gives us the ability to emit events. But when it is a snapshot of contract state, only read access is allowed and emitting events is not possible. So with this, do you know that I've been working with events and I've not noticed this? So with this, it means that you can only emit events when you are changing states. But once you are getting the snapshot of the state, you won't be able to emit events. Well, we're going to try it and see. All right. So to access and modify the contract state now, that means we are now implementing the functions, the set and get functions. The two methods are commonly used to access or modify the state of a contract. Read, which returns the value of a storage variable. This method is called on the variable itself and does not take any argument. Self.storedData.read, then write, which allows to write a new value in a storage slot. This method is also called on the variable itself and takes one argument, which is the value to be written. Note that write may take more than one argument, depending on the type of the storage variable. For example, writing on a mapping requires two arguments, the key and the value to be written, just like this. Self.storedData.write, then pass in the argument you want to write into the mapping here, or into the storage here. All right, so That is the overview. That is the anatomy of a smart contract. Do we have any question?
So, if I understand you correctly, yeah. So, if I want to write interfaces, I have to use traits for the interface. Can I use traits without like interface? Like I just want to write normal traits instead of using interface.
You just want to write normal traits.
Like this trait now, can it be only used under interfaces?
Yeah, that is what trait is majorly.
So if I want to declare a state, I must put that what did they even call it that they said? This Starknet interface. I have to put it at the top for to write trait. I can't write traits like just straight up like that. So I have
Okay,
to use it
let's write the
under
trait.
yeah, like I want to use traits like normally inside my code.
Okay,
So
yes, you
it
can
has to come with
work
that
with
interface.
traits. No, you can work with traits. So you mean something like your TypeScript, right? How you just implement a trait. Yeah,
Yeah.
yeah, you can implement your traits like that. But I really haven't done anything like that. I only did that, I think, once, and that was for a normal Cairo program. And I think Rust also. Yeah, but for a smart contract, if you are writing a smart contract, you cannot just implement traits. Trait is an interface. The trait is actually the interface. So just like your Solidity, when you want to write an interface of ERC20, you put I ERC20. In this one, it is the trait. In this in Cairo, the smart contract, it is traits that you use to define the function signatures that you want to be implemented.
This makes sense. Thank you. I understand it.
You're welcome. Okay, any other question? The guys, ask question now. What's going on?
Questions are coming, but not yet time.
The questions are what?
When we start doing the practicals.
All right. So everyone is clear. Like it is very, very clear to us what I'm trying to explain, right?
Yes. It's clear.
Okay. All right, cool. So having explained that, my next task. Okay. So that is the anatomy of a Starknet smart contract. Here is building a Starknet smart contract. So at the anatomy, it explains a very, very simple Starknet smart contract. So understanding that gives you the foundation you need to build upon when writing your Starknet smart contract, no matter how complex it will be. Starting from there gives you the foundation, and understanding it gives you more clarity when building your smart contract. So in building Starknet smart contract, can I go through this? Okay, I can go through it for start. What is time? Okay. All right, so in this session, we'll be taking a deeper look at the components of a smart contract step by step. When we discussed interfaces, we specified the difference between the two types of public functions, i.e., external functions and view functions. And we mentioned how to interact with the storage of a contract. At this point, you should have multiple questions that come to mind. How can I store more complex data types? How do I define internal/private functions? How can I emit events? How can I index them? Is there a way to reduce the boilerplate? Luckily, we'll be answering all these questions in this chapter, considering these smart contracts. So this is a full smart contract, the reference smart contract for this chapter. And let's just go through it to understand what it's doing. Now, in the previous one, it just gave us a foundation of a smart contract. But in the reality, when you are writing a Starknet smart contract, you start with this flag on top your file. So use Starknet contract address before you go to your interface flag, where you put your traits or public traits, the name, and this one takes three functions: store name, get name, and get owner. Store name is a write function and it takes in the parameter of name as a felt 252. We've done data types, right? You guys have done data types in Cairo, right?
Yes.
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 Okay, cool. So it takes name as a felt 252. It takes registration type. A registration type is a name registry type. So this name registry should be a complex data type. So we are going to check what this data type is. Sorry. We have function get name, which is just a snapshot of contract state. To get the name, you pass in the address. Address is a type of contract address. And then seeing this, it means that this function is meant to return. It's meant to return a felt 252. That means it's meant to return the name. And the get owner is just a snapshot of the contract state and returns from the name registry person. So either this is a struct, probably this is a struct. So name registry person, and here it is returning registration type from name registry. So when I say, when you have this colon, what it means is that you are trying to access a function that is in another implementation block, right?
Yes.
Yes.
Yes. But
Yeah.
this name registry is a module.
Exactly. So it is in another block from the traits. This is not here. So to access this trait here, you have to use super.this. So to access anything from here, you record the name of the module and the name of the item you are trying to access, like this. Name of the module and this. So I feel this is either a struct. I'm not sure it's a function, but let's go through it with it. Okay, so this is the module name registry. It is using Starknet contract address, get caller address, storage access, storage base access address. It calls the struct flag, storage flag, with the struct storage. And this struct storage takes in the following field: name. Name is a mapping of contract addressed to 4252. Owner is a person, so I feel this person is a data type. So it is either a struct or something else. Registration type is a mapping of contract address to registration type. So this registration type too is also either a struct. It should be a struct. Then total names. Total names is a unit 128. So this is the information that will be stored to storage. And it is emitting an event. To emit this event, you need this flag called derived drop and the Starknet event. So to emit an event, use an enum to specify the event. Stored name is a data type of stored name. Now this stored name would have to be a struct. So after specifying the event, they gave us the event and the data type in the enum. Now we have to implement this data type called stored name. And to implement this, we use a struct. Also, mind you have to still call this flag derived drop Starknet event. Well, when you call this struct stored name, you have to pass the key flag that serves like an index. Thank you. So taking in the user, the contract address of the user, and the name of the user. And if you have different events, if you want to emit more than one event, this event would have all the different events you want to emit. So stored name will be stored name, maybe write will be write, read will be read. Then the way you implemented a struct for the stored name, you will implement this same thing for the different events and the various parameters you want the events to emit. Now, also note that this struct stored name is not a storage struct. This struct has the storage flag. This is a storage struct. So everything here is either writing to or reading from the state. Okay? Any other thing you define outside that is important, that is needed, you have to make sure you call it inside this storage to be inclusive here. So the things you cannot implement here that you want to do the computation outside the storage, they'll be done outside the storage, but then their value will be stored here finally. So we have stored name. Stored name is the event. Here we have derive, drop, sed, Starknet, store. And we are calling a struct called person. It's passing the address and the name. Now, we couldn't do this inside here because you want to remove most of the implementation. Is it implementation I'm trying to say, or computation, or whatever from here? And also because we are trying to instantiate this as a mapping, legacy map only works in this storage struct. You can't call legacy map outside. So since legacy map is what do you call it? Is a mapping that contains a key and a value, you can just do it this way, where you have a struct that has a key and a value, and then you pass it here. So whenever you call owner, it will call person and return person to you. Here is an enum, still passing the flag derive, drop, set, Starknet, stop. Okay, this is for the registration type. Either it is a finite registration or an infinite registration. And then it is called here for registration type. So once you pass in the person's address, you should see the registration type for the person. So all these extra structs, enums, or whatever help you to move most of the computations and complex stuff from the storage. You do them outside and finally pass the values here. Okay, so hope we are good. Next, constructor. Once you have a constructor in your code, you have to pass the constructor flag. Passing the constructor flag makes it know that this function you are calling or implementing is the constructor function. So this constructor takes in is a reference constructor. Normally, all constructors are reference now. They are right functions because the state is always initialized as empty. Is a constructor that puts the first inputs or the first values to state. So the constructor references itself and then takes in the owner before you can deploy it. So to instantiate this, you have to first call self dot names dot write. Self dot names dot write. So you know that anything in this constructor majorly is implemented from this storage struct. So it is only things from this storage struct that you can easily call like this self dot names dot write. So we call this names is a mapping. So it takes in two key and value. Key, contract address, value, field 252. So once we call names dot write, it takes the key, the owner dot address, and then the value is owner dot name. Remember, owner, right, is a person struct and it has address and name. So to get the address, you just say owner dot address and owner dot name. Then self dot total names dot write. You pass in 1 because you are instantiating it now. Then self dot owner dot write owner. So what this means is you are instantiating this, passing this owner as the parameter to instantiate this constructor. Owner takes in two fields, two inputs. So whatever you write in the first input of owner, it will take it as the first item here. And whatever you write in the second, take it as the second item here. Push these ones to names. So in this struct, names now have one person in it. Then self dot total names dot write 1. It will come here. Total names, instead of it being 0, will now be 1. Then self dot owner dot write, this owner here. Anything you pass into owner will be passed here. So you've just instantiated the owner as a person. So you have passed this thing, value to address and to name for this particular owner. So anytime you pass the address of this owner, you are supposed to get the information of this person. All right, so instead, let me not confuse you guys too much. This is what the constructor does. It instantiates the values in the struct. Now, we are going into the implementation of the trait. Because the store name, the get name, and the get owner. So store name is a reference to self. Now, if you can remember, it had T contrast state in the trait. Now, in the implementation, you have to get rid of the T. Name is a FELT 252, and registration type is an enum called registration type. Now, to instantiate this, you say let caller be equal to get caller address. And then self dot store name. You pass in the caller. What is going on here? It is calling itself here. You pass in the caller, you pass in the name and the registration type. So what happens next?
I think store name is an internal function, like a private function.
Okay, unless there is a private function here that would not see.
And that's it.
Oh, wait. Oh, okay, underscore. I just saw it. Okay, so it is self dot underscore store underscore name. I thought it was this one. All right. And then the function get name. Get name just self dot names dot read address. Whatever contract address you pass here, it will go to these names. You know, names is a mapping. It will pass the address here. If there's any address like this in the mapping, it will return the name for you. So self.names.read returns the name of the address you passed in. Then function get owner is to return a person struct. So it will return self.owner.read. So what do you think is going to be the output here? Let me be sure if you are following me.
So it's going to return the person struct. So the name and
The name and guys, what is
The address, the name and the address.
name and the address? Which name and address is it going to call the?
For the get owner function, is the name and the owner of the person that deployed the contract, at least, or the name of the name and the address of the person that actually passed their name during the deployment as one of the constructor arguments.
Okay, thank you very much. I just wanted to be sure you are following. All right. So that the owner.read is going to return this person here. So whoever is here is who will be returned here. All right. Standalone public function. This is an external function. Function get contract name. Mind you, this is outside the module. Get contract name. So just the name of the contract. So you know this one, you don't need to do too much work for it. This is the name of the contract. You already know the name. It is not going to change. So it just they just called it name registry is the name of the contract. Okay. Now this is a private a private function, internal function. Now with internal function, we have something called generate trait. When you pass this flag and you call generate trait, you know what this external trait flag does, right? It makes this function external. This generate trait, what it does is any function you call, you implement here, because this is an implementation of internal functions. Any function you call here, the generate trait behind the scene will generate the trait for it. So you don't need to regenerate the trait for this. So whatever name you give this implementation, just know that the trait will be the same name plus trait. So we call this in internal functions. So the trait name will be internal functions trait. Automatically, generate trait will generate the trait for this private function. And what do you think it will generate? Even though you are not seeing it on the contract, just looking at this and with the idea, with the whole story I've been telling you about, considering the VM, considering the compilation, everything that happens, what do you think will be generated here during compile time as a trait for this?
The function signature for store name.
Please, I don't want Benjamin to talk again. Sorry. I don't want Benjamin, Vicky, or Emmanuel to speak again. Or Abraham. This four. I don't want to be able to speak again. Sorry. I want another person. Once this is compiled, what traits will be generated for this implementation? Emmanuel Okeke, David Dada, Kemi. Okay. Aji, Nefisat, Oluwa, Femi, Steve. One of you should answer this question. What trait will be generated here? Where are you
Someone
getting
said
function from?
okay.
Where are you getting address function from? Where is get address first? Are you trying to say this one? Get owner storage address. Is this what you mean? This is not part of our implementation if this is what you are referring to. And store name is not the way the trait is going to return it, judging by how the trait is being formed. So yes, you are halfway there, but this is not fully correct. Complete it. Kemi, what's going on? Aji.
Hello, ma'am.
Mm-hmm.
Yeah, sorry, I didn't get the question.
So I said, looking at this implementation, right?
Yeah.
The generate trait would automatically generate the trait for this implementation. So what
I can't hear anything. My phone is.
You can go.
All right, sorry. I'm listening, please.
Yeah, so I'm saying once the trait is generated for internal functions, what would the trait look like? Here we are implementing the trait.
Okay.
So what would this internal function trait be?
A store name.
Hmm?
Contract address. Let me answer. You not let me answer. You're not saying.
Wow. So you're asking someone for answer. Amazing. All right. David, you are so close. There's just one thing out. You've gotten everything, but one thing is off. One thing is not correct. Just one thing. If anybody knows what that thing is, please speak up. Anybody can speak now.
All right. He made mention of the contract state. It should have been a generic type instead of the actual contract state.
Thank you very much. So what was it supposed to change there? So what is it supposed to change here to make it a generic type?
Okay, sorry. The contract state.
So David, you get, well, this is cool. I'm happy you people are getting it. So here, where you put ref self, in the trait, it will be T contrast state. It is in the implementation that you just call it contrast state. Okay, cool. Nice. We are following. All right, so This is the implementation of the internal functions trait, and it's a store name, and it is the contract address L252, the name, and the registration type. Then what does it do with it? Once it gets it, it creates a variable total names and say total name is equal to self dot total names dot read. You know, total names now at this point, our total name is 1, right? So that you here, when we deploy this contract in the constructor, we set total name to be 1, right? You remember, right? So we have something in the total name. So now we want to add another information to the struct. We'll first read what is in the struct, the total name, then self.names.write, user, and name. User will be this contract address. Name will be this felt 252. Then self the registration type dot write still pass the user contract address and pass the registration type that the user selected. Then self the total names dot write will read the previous number of total names and add 1 to it so that it gets updated. So it will read what total name is currently, then add 1 to it. So at this point, the total name will be 2. Then self.emit. So now we want to emit the event called stored name. And stored name has user and name in the struct. So we pass the user address and we pass the username. So this implementation has been done in this internal function, and then we can call it here. Self.storename, we pass in the caller. Here, it is supposed to be user, right? User is the contract address. And our user we are referring to is the caller. So in Solidity, in Cairo, get caller address is similar to msg.sender. So whatever address is calling this function is the address we want to be saved here as caller address, as user. So this person address, and the person will pass in the name, and then the registration type will be passed in. And then this store name function will be implemented. Okay, so that is the work of the store name. And the work of the internal function is to get the implementation of this store name so that it does the implementation as an internal function and then passes this to the public function. Then there's also a free function, and this function doesn't have any flag attached to it. So without any flag attached to it, it will not be accessible to the public, but it can be called within the contract. So get owner storage address is reading the snapshot of the state and is returning a storage base address and calling self.owner.address. Okay, so Owner is a person, so it's getting the address of the owner. So storage base address was imported from storage access from Starknet. Okay, cool. So the right in the storage access, to access the storage, there's a storage base address. So I think what is going on here, I'm not really sure. What do you guys think is going on there? Vicky, you can speak.
Okay, so just to be clear, yeah, this generates traits. So that
Yeah,
means you don't need to actually have that trait. Immediately you do the implementation, it generates the traits for you.
yes, for only internal functions.
Only internal functions.
Yes.
Or I don't think I get it.
Like only internal functions. If it's a function you want to expose, you need to generate the traits. And then the implementation will be the functions in that trait. But it's an internal function that you are not exposing. So everything you implement here, generate trait, will generate a trait for it. But if it's like an external function, you know all these functions are external, right? They are public. You need to have generated the traits. You have to generate the trait for these. You cannot just use generate traits for public functions. Generate trait flag only works with internal functions.
Wait, so if I'm just using it internally, that's in only my contract, why do I need the trait?
The trait is more like I said, is the interface for your contract. So you really can't do anything within your contract, or yeah, anything within your contract without an interface. There has to be a structure as to how that function will be defined or called. Because I'm not so sure of this, but everything at the back end works with function signatures. And that is what is checking the correctness of your implementation. So if your implementation is not following the correct function signature that has been defined, it will return an error because it's expecting a specific type. So for the interface to work, for your implementations to work, it needs an interface. The interface defines the structure of all the functions that will be called in your smart contract, and then will be implemented later on. So for this one, you don't need to define it, but if you want to define it, fine. But there's already a predefined method that is stored in this flag that helps you to define your traits, your internal traits. This is a public trait, so it is external. This will only generate a trait for you for this internal function. All the functions that are listed in this internal implementation, the trait will be generated for you because it has already been abstracted and called in this generate trait flag. But this
Yeah,
works with internal. Yes?
So on my
Yeah,
on
this was exactly what I was asking about earlier for the internal functions. Can I get it?
Okay, thank you. Victoria,
okay, so all my functions, right, would have to be inside and implement that in I can't have like a function just be on its own because I don't know.
You can, like this function we see here.
So my idea of interfaces, right, is that you use it as a structure so that anyone that wants to use your contracts can just get the interface and get the contract address and just implement it just like it is in Solidity. But now I'm seeing that I'm generating traits for private function. Like, why do I need interface for a private function? Since other contracts will not be able to see it to implement it. It gets, I don't know if I'm making sense.
Yes, yeah, you're making serious sense. You're making serious sense. Okay, let's check why private interface is needed, right? I don't really, I didn't really pay attention to it, so let's check it out. So it was explained. It was explained somewhere around here. Private functions. So let's understand it. Functions that are not defined with the external flag or inside a block annotated with this are private functions, also called internal functions. They can only be called from within the contract. They can be grouped in a dedicated implementation block, in components, or easily import internal function all at once in the embedding contract, or just be added as free functions inside the contract module. Note that these two methods are equivalent. Just choose the one that makes your code more readable and easy to use. So what are the two methods? This could be a group of functions about the same topic, or this, it could be a free function. So what is generate trait attribute? Where is the trait definition for this implementation? Generate trait attribute is a special attribute that tells the compiler to generate a trait definition for the implementation block. This allows you to get rid of the boilerplate code of defining a trait with generic parameters and implementing it for the implementation block. With this attribute, we can simply define the implementation block directly without any generic parameter and use self as contract state in our functions. The generate trait attribute is mostly used to define private implementation blocks. It might also be used in addition to ABI per item to define the various entry points of a contract. So you can see this next session. Using generate trait in addition to ABI embed attribute for a public implementation block is not recommended, as it will result in a failure to generate the corresponding ABI. Public functions should only be defined in an implementation block annotated with generate trait if this block is also annotated with the ABI per item attribute. Okay, so you can use generate trait for your public implementations also based on this, but it is not recommended. As you can see here, it is used for private implementation blocks. And using the generate trait gives us this self in our functions. So if you can remember, when we wanted to call When we were implementing store name, we used self dot underscore store underscore name. It gave us the access to just use self underscore store underscore name because it was defined here. But then I'm looking for where this was called, so we see the difference. So if you don't want to use trait to reduce your boilerplate code, this is what you do. You don't declare the trait anymore. In your module, you put your flag ABI per item and then generate traits, then the implementation, your constructor, and then for every function you pass into this. If you want that function to be public, you add this flag external attribute to make it public. So if you are using this method, you can implement both your private and non and public functions in the same implementation block. The difference will be the flag you will be passing to it. So if you don't pass any flag, it is an internal function. But if you pass this flag, then it is a public function. So if it has a ref, that means it is a write. And if it doesn't have a ref, that means it's a view function, view public function. So yeah, I think with this we have gotten the whole use of generate traits, but it is majorly used with these internal functions. Because if you check standard codes of serious projects in the ecosystem, they don't do it that other way. Unless maybe new projects are coming out or some security threats and stuff that makes them implement it. Or maybe they just want to just do some crazy stuff and then they implement it that other way. But this is the standard for writing smart contracts. At least it is more readable and understandable. Imagine seeing this as a start. Where are you? Imagine seeing this at a start. Would you understand what is going on here? If you've not understood the concept of the traits, generate traits, ABI per atom, external, you wouldn't understand what is happening here, right? Or would you? It doesn't look readable. Am I talking to myself?
No.
No.
Yeah.
Better.
So if you see it this way, it doesn't really look readable and understandable. It needs someone that has really been writing the code to understand what is really going on here. But with this, it's still not very readable, but you have an idea. You see that it is called an interface, and then you see it implemented here in this implementation. You see the constructor and stuff. It makes it easier to understand what is happening. Here you see it is calling this function, and then you see the function here. So without understanding so much about Cairo, you can kind of deduce what is going on here because it is more readable. But once you're an OG, like Victoria, then you can write it the other way. So I'm trying to understand. I'm trying to see where this was called. I'm trying to see where this was used. Because if it isn't called anywhere, you can't call it once it's deployed. You won't even see it because it's an internal function. You only see it in those ones are internal transactions. I don't think you would see it. Was this called anywhere? It wasn't, right? Get owner storage address. It wasn't called anywhere here. Okay. So it wasn't called anywhere here. Storage base address. It wasn't called anywhere here. Yeah. All right. We're going to find out what that is used for. That last function. Okay, so next. So far, are we clear? Is there any other question? Okay. Any further questions? If not, then are we good to go? Should we start writing our smart contracts?
Yes.
It's only Vicky and Emmanuel that is in this class. What's going on? Are we tired? It seems I've talked too much.
No, we are
We're
not
just
tired.
waiting for the action. Okay. Um, okay. Is this readable? I'm sure this is readable, right?
Yes.
Okay. So we want to bootstrap a new Cairo project. So how do we create a new Cairo project? So we are sure we are following. So call it for me while I type it.
Stab new.
Oh, who said that? Benjamin.
It's Abraham.
Abraham. Okay, cool. Okay, so what is the name of the project? What name should we give the project?
Our first smart contract.
Hmm, hmm, hmm. Okay, cool. We have instantiated our first smart contract. So new window. Okay, I think this is readable, right?
Yes.
Okay, thank you. So what is the next thing we need to do?
Edit our TOML file.
Thank you. So what should we add?
Under the dependency to add our Starknet
And then the targets.
Okay. So we are adding this. We're adding this to the dependency, and then we are adding the targets to compile to Sierra and we save. Okay. So src lib.cairo. Don't need all these things. Okay, so first thing we do use Starknet. So what are we calling? Contract.
Contract.
Okay, cool. So the next thing is our traits. So before we call the trait, it has a flag. And the flag is called Starknet what?
Interface.
Is this correct?
Hopefully. Yes, that's correct.
Okay. Hmm. Do we need anything else? Why is it crying? See? Doesn't need anything else. So, okay, let's just call the trait. So what are we building? What is our first contract about? Give me ideas now.
Let's say to do
Get
this
name.
for
What?
But
What? Who is
can
speaking?
you get name
Get name.
and set name?
Asset name.
Okay.
let's do to do list.
Oh yes, to-do list.
Okay, to-do list. Okay. Why are you shouting?
Maybe we are not supposed to use for
Yeah. So what are the functions for to-do list that are needed? Yeah. Add, to do, right? Right?
Yes.
yes.
We need to add it to do. And name. Does it take any parameter? To add it to do, what does it need? It just needs description, right?
Yes, and maybe deadline if you want to add that.
Okay,
Name
so
and
Title and
description,
description.
name and description, and then status.
name and description, right? What is the
Status.
D for? Okay,
Title.
to tie the to do to a person.
Title. The title of the to do.
Yeah, what the title? What do you mean by title? If there's a description, what do you need title for?
Just like the general idea of what the to-do is about.
like a header.
I'm not, if you say list, you
We
major
can
see number one, and then the name of the to do you have to do, and then the next thing you see is if you've done it or not. So I don't understand what you mean by title. Can you like explain? We're adding a to do now to a list. So what is the title there for? Is it like, what is it for? I think what we need majorly is just the description, right? And deadline, probably.
Yes. Yes, yes.
Okay. So description of the to do and deadline. And deadline is what? What data type is deadline?
U32 should be enough. I don't know.
Use U22.
U size.
Use size. And then the deadline will be returned as an epoch time now, right?
Yes.
U32 can U32 handle epoch size? The current epoch size? Can someone check? 1 times 2, is it 1 times? 2 raised to power 32 minus 1. 2 raised to power 32. What am I doing?
Epoch time is actually in 32 bits.
Yeah, but it keeps on increasing. Epoch time is seconds. Is the number of seconds since the world started. So, as long as the project continues, the epoch time is going to increase. So if they want to use this project in the next 20 years, the epoch time might have grown from unit 32 to unit 64. I'm just saying, what is the current epoch time? Is it within the range of unit 32 at the moment? So we
Yeah,
continue
it's
the
actually within the range of U32, but I think after like 20 years, it should expire. Like, it should go back. I don't think it's up to 20 years again, Sha. But
okay.
countdown will soon end for 32 bits. So,
Okay, so we add to do. Are we expecting it to return anything once we add? It should return a boolean, right?
Yeah.
So what's other function?
You can update.
Get to do.
Get to do.
Update. So if you want to update, click update description and deadline. Okay. Then someone say get to do, right?
Yeah.
So if the get to do, because it's a list, it should probably be an array. So this will get to do's first, and then self at contract state. We don't need to pass anything. And then it returns what? How do you call it? Array?
iterate.
Sounds array trait on new.
I think when you are
Array.
defining,
Sorry.
okay, array without, yeah, array without a trait, I think. I don't know. Abraham,
Okay.
Sir.
Well, we'll check the documentation. Anything wrong there, we'll fix it. So function get to do self at and then we pass the index, right?
Yes.
Index would naturally not be more than. So what will it return?
A struct.
Yeah, it's supposed to return instruct. Okay, let's just proceed, then we'll come back to this. So once we want to update also needs the index of the particular to do we want to update, right?
Yes.
Okay, so we are sure of the first two, but the last two, ain't so sure about it. So what is the next thing? Starknet, contract.
Contract.
Okay, cool. So next, mode to do. The mode to do. And in this we have storage. We have our struct. So even though you do not implement struct, you can just leave it like this. If not, your code will not compile. If you don't have a struct, a storage struct, right, in your Cairo code, it will not compile. So we'll still use this in the mode. And then next, to do, we don't need to instantiate it with anything from the beginning. We do not need a constructor because it's not supposed to have any information, right?
We can set owner.
What?
Can initialize owner.
Okay, initialize owner. Why do we want to do that?
So that the owner will be the only one that will be able to update some things.
Okay, okay, cool. So constructor owner is a contract address. Okay, so we can either use the caller at this point using get caller address.
Yes,
But it seems it is slightly different when you're working with get caller address. When it comes to deploy. Okay. Let's just
I think you have to import it to use it.
yes, we have to import it. I'm just thinking Let's just do it. If we encounter any error, fix it. So get caller. Why is it not auto completing? Get caller address. So I think I want to write something here because I want to check properly. Owner. The contract address. So let's caller be equal to get caller address and then self dot owner dot right. We don't need this anymore if we're using caller address.
Sorry, but I don't think that will work because the caller will be the deployer, the universal deployer.
Exactly.
So that's why we need the owner.
That is who will be the owner.
No, that's why we need the owner in the constructor, but we don't need the caller for this step. It's only we are trying to check.
That's what I
what
was
we
saying.
need the caller.
Get caller address will be the universal
So
deployer.
we'll have to add code the owner.
So we have to add code the owner. Yeah. So we have to hard code the owner. Okay, so this is all we need for the constructor. Okay, that's all we need, right? Are you guys still with me?
Yes.
Yes.
Okay. So, okay, so next. What's next?
Yeah, our public functions.
Okay, cool. So how do we start?
And
So
the
we have
tag ABI, blah blah blah.
then embed, right?
Yes.
That's
And
for
the 0 V0.
V0. Like this.
I'm not sure.
Yes.
Why did we use V0? Underscore. Okay. I don't know what's up. Let's continue. Okay. So now we are implementing to-do lists. Is it for? Off. So I was saying we could use the use our first smart contract or lib to-do list, to-do list here, or we can just write super. And here we are setting it to contract states. Okay, so another thing we need to do is create a folder, a file called todo.cairo. Sorry, I forgot. That was the first thing we're supposed to do once we came here. So everything we copied here, cut it and paste it here. Your to do. Lib.cairo is where you add your modifier. So we are adding mode to do. So it's going to be reading this to do file for us. So I hope you guys got what I just did. All right, so the first thing we want to do is implement add to do. And to add to do, I'll just copy this. So to add to do, where are we adding it? Where are we meant to add the to do, the new to do to? So which document are we to send it to?
I think you need a struct actually to
Okay.
hold the data.
Okay. So in this struct, we can have something called to-do list, right?
An array of to-do list, right?
Yeah, so we cannot have an array in the struct, but we can have a legacy map. We can have a mapping.
Sorry, ma, I have a question.
Yeah.
What's the difference between this legacy map and dictionary?
Legacy map is a normal mapping in a normal mapping. Dictionary also helps you to do mapping, but not in the struct, not in storage. So
Okay.
legacy map, yes, helps you to do add your mapping to storage directly. But dictionary, you can do it outside, and then the value you send to one of the variables that will hold the results in the storage struct.
Okay.
Yeah, so for to-do list, so what are we supposed to pass? To-do list should have, you should take a unit 8, right?
Index. Yeah.
As the index. And what
That's
should be the value?
struct of to-dos, I think.
So to-dos. Okay, so we need to create a struct. And to create a struct, what was the flag? The derive, right? We're deriving what? Drop, derive said, right? And we derive, was it Starknet store? Was it store?
Yeah.
Okay, let's just check it. Is it this one? I think here. Sorry. Okay, yeah, this. So we derive drop, set, and Starknet store. So this drop should be capital. And then make it a public. But why is pub giving me issues? So struct to do's. Should it be to do's or because is this list that should hold the entire to do's, right? If I'm correct.
Yes.
Yes.
Yeah.
With the to do, and the to do will take the description, right? Take the description.
Deadline.
Description is a felt 252. I should take a deadline of unit 32. And that should be all right. And what else? How do we make sure this value
We can have like something like an ID inside the struct.
this struct?
Yes, we can add like ID. So we are able to track what to do. Uh, exactly.
Okay, cool. So we use the ID as the
As the key.
key. Okay, cool. All right, so next, should we do the implementation here or let's do the implementation in an internal trait? Okay, let's do it in an internal so we get fully used to everything, right? And
Yes.
now start our learning in the right track. Generate traits. Okay. So we are implementing private implementation of private implementation traits. And we need function underscore add to do the same information. Shoot, shoot. I need to return anything. Return in the main. Okay, so to implement adding to do, what do we need to do? So we'll call self dot description, right? Self dot, sorry, what is the
How
name?
about the list?
Self dot to do list. dot write. And what we are we writing?
Our key.
So ID, how do we track this ID?
Can be
Um,
40, a big one, 0.
the 0.
You can start from 1 or 0. No.
We are meant to read from this. How do we
Yes.
read this struct? Can we read like this?
Yeah,
Same.
we can actually
Yeah, we
access.
can read. Yeah, we can do that.
Yeah,
Can say
okay.
self dot to do
Self dot to do lists
Self
from
dot
the
to
from the storage.
this one.
Yes.
Okay, cool. So self dot to do list dot read.
yeah.
So what are we reading? To read, we still need to pass in the index. And I'm trying to get the index.
Okay, sorry, but if we want to do that, depend and based on this our what do you call it, the way we are implementing it, we'll need to like have what do you call it now? A
So I
variable like
to have
tracking
like
the
this.
index.
This is what they used. We were using this to track how many people
We can do this. We can have
study. Can you see?
yes.
Like they use this to track how many registration had happened.
Yeah, yes, we can have it outside. So
Yeah.
as we are adding to do it to be incrementing.
Yeah. So to save us stress. So let's call it to do ID. To do ID should be a uint 8. So at this point, we'll be reading to do ID instead. Please, all the rest are following me.
Yes.
Okay. So now we've read what to do ID is at this point. The next thing is to write. So self dot to do list dot write ID. What is it taking? To do list is only taking
ID and destruct.
and destruct. Okay, so that is ID. Whatever ID is plus. No. It will be self dot. Sorry. Once we've read it, then
ID
write
plus
current ID, right? Be equal to ID
plus 1.
plus 1. So that is what we'll pass in here. Current ID. Then
Can't we save like using the key, and we can say let so variable equal legacy the to-do list, so that we'll be able to initialize our variables, I think.
yes, as the key instead. So something like this, right? Where we called owner as the variable and calling
Yes,
this.
owner dot name, owner dot start.
So for here, But let's see. Okay.
We'll have to save it inside the variable first.
So what should we call it? To do. To do should be the to do struct.
Yes.
Okay, so current ID. Um, um, so do we need this ID here? So let me be sure of what is going on here. We have another address, another name, and this takes in to-do list takes in this and the to-do. So
So
is it
the
to
second
work?
the second parameter should be the struct.
Yes. So that means we should initialize the struct first.
Yes, that was what I'm saying. We first create initialize the variable for the struct.
Because to do, right?
Yes.
And then we just pass it. What is ID should be current ID. Description
You have to bring back those are
the
arguments.
description.
That's
Uh,
okay to do dot description.
yes, or you can just do it this way. If not, we'll pass it here as what is the best way to do this?
Instead of description, you can just say to do.
Yeah, to do dot description, right?
To do column. To do column to do.
But won't the two to those be shadowing each other?
Yeah, that is shadowing here because the
Doing
parameter.
we can let's see.
So there's a to do in our parameter.
Say to
Or
do
you don't even maybe we don't even need to add another like
this.
can just bring in that one inside. No need of it to do dot anything. Can just use the to do that is in the
Okay, we
parameter.
can just yes write it straight
Mm,
to the to do
yeah,
list.
like straight. Yeah.
Yeah, but the current ID should be defined inside that struct.
Yes.
Yeah, that's true. That's true. That's another thing to consider.
Dot ID. So we need to initialize that to do first.
We need to initialize that.
So let's follow this and see how they initialized it. It just wrote the address and name. And this owner only needed address and name. And this our to-do list needs okay. We need description and deadline. Okay. And description and deadline. Description and deadline. Then we need something else. ID and to do. So our to-do list needs description and deadline, ID and to-do. Or we can make this a 2D mapping instead. So as a 2D mapping, it takes in the it doesn't need, it's not supposed to be a 2D mapping. So suppose if it's a 2D mapping, then that is when we can easily initialize this, then this.
But I'm sorry, but I think we can just define the to do normally, and then we'll just write it into the legacy map the normal way, self.to-do list dot write the ID and then the legacy map. But first of all, we need to define the to do itself. So maybe instead of passing the to do directly as a struct, except maybe you want to generate the to do inside the add to do function and then pass the to do struct directly, or we just pass the description and the deadline.
Let's see this first. So let's to do be equal to so I think ID. So ID should be current ID. Then description should be description passed. And deadline should be the deadline passed. So here,
Can just pass our to do here.
just pass to do. This is supposed to work. If everything is okay, this is supposed to work. Okay, so here where we have add to do, we'll just call self dot add to do and pass description. That's what it needs. And deadline. Right? And we'll return true because it's returning a boolean. Okay. So okay, so what next? Let me add a function. Let me add a normal function to read this to-do list. So this function is to get to-dos. But if we are returning it, if we are calling it, we need to add a key, right?
It's true. It's true.
If we are returning this, okay, yeah, if we are returning this, we need the keys to be returned. So you get what I'm trying to say, right?
Yeah, we can actually create an array that we can push this struct to
So
each time we create a TP.
cool. Okay, so the next one, let's just get to those. To get to those is Okay, so to get our to-dos, sorry, remove this and this and this. So we need to import array. So use, I think it's core array create. You can check it so that we are sure we are on the right track. So to get, okay, let to-dos be array create new, right? So we initialize to-dos as an array. So the next thing is we want to read. And to read, we want to use index to read. So we can do a loop. So I, or does it work without this?
It's just to define the keyword loop.
Yeah, sorry. Almost my brain.
What trust?
Sorry. Okay, so we loop, and in the loop, so what are we doing? What's the next step?
I think we'll need to define two variables outside.
Yes.
One will be the total to do count, and then the second one will be the index that we'll be using to read the legacy map.
So what is the count?
Count to be self dot read. I mean self dot use count. I mean, how do you call it? Self. I forgot how we call it.
Self dot to do
Do
ID.
I? Yes.
Right.
To do id dot read. Okay, cool. So what is the
But the
next?
problem now is after our add to do, we did not increment to do ID.
Yes, we incremented it before adding. Yeah.
Yeah, but it will not reflect on the to do ID in the struct or would
Oh,
it?
sorry. This was just reading. Okay, yeah.
Yes.
So that's the last thing. I actually thought this was self dot to sub blah 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 read write. Thank you for reminding me. So write current ID.
Yeah.
Okay. So it's complete. So here,
Current ID plus ID.
what you said? Did anybody say something?
No, you can go ahead. You can go ahead.
So let me quickly check the loop function to be sure I'm on track. Is there anything for looping?
General programming concept. Common programming concept rather. Number two.
Okay, thank you.
Control.
Okay. So we'll be checking if index is less than um if index is less than current count plus 1. Should it be current count plus 1?
You can use while instead. While is easier.
While index is less
You
than
can just say while index is less than.
current count plus 1.
Yeah.
Cool. So hope we are together.
No, while is another loop on its own. Yeah. So instead of using loop, you can use while. While.
While is another loop.
Yes.
Okay. This. So while okay, cool. I'm feeling weird about this. Okay. While index is less than count plus 1. Okay. While index is less than count plus 1, append. Should we append now? Let's read be equal to self dot to do list dot read, right?
Yes.
Yes.
Index.
And
It's only the index we need.
yeah, it's just the index. Thank you. Let the read. Then to do.
Oh, is read not a keyword? Or it's not give us error.
It is.
Let's so
Because
let's
they read
do.
to do. Yes.
Okay, so the next thing is to do's dot append read to do. Okay. Then there's no break. Index
Then you increment.
is
But I don't understand why we are doing count plus 1.
Plus one.
you know, if we say index is less than count, it will never be equal to count. Or should we put while index is less than or equal to? No.
But when it gets to
So
equal to count, it will stop, right?
yes,
If
it should stop.
we use less than, it will never be equal to count.
But since index is starting at zero, why is it like plus one again?
I think the problem is coming from the way we actually implemented it. The index should actually even start from 1 from our implementation, because the first ID we'll be having when we start is 1. So I think if we want to have it start from 0, we have to move the addition after the this thing. So here we
Why
can
the
stop at count
that is
plus
not
1.
one?
We can stop at count plus 1 because that particular index at that moment is the last item on the to do, because of the way we implemented it actually.
We didn't
I get it now. So
we didn't implement ID to start from 1. We just read it and just added 1 to it, where whatever it is. Array start from 0, index start from 0. An index in an array,
so
counting index starts from,
index starts from 0.
and here
Since
we are saying
since index starts from 0, then we don't need
0,
the plus
and we are
1.
saying plus 1. Do you get what I'm saying? In
Yes,
the
yes, I get.
index, actually start from 0, but here we are passing the ID as 1, and we are setting it into this to do and into that our storage struct. So if
Okay.
it is 0, it is actually not 1, and that is why I am adding plus 1. So once it's
Okay. Got
so
that.
whatever the last count is,
The plus one I was asking about was the first one in the while, Sha.
yes, now this in this while, this
Yeah, yes, that
one,
one.
we are reading. Okay, what is to do ID?
So index should be 1. Our index should be 1 in this get to do's then.
Oh,
Since our starting
okay.
point is
You
1.
see, we started. Okay, this is where we started. Thank you. We
Yes.
don't need it. We don't need the plus 1.
We need it, ma. We need it based on the fact that our index is starting at 1. Since it's an array, yes. Sorry. Yes.
I'm
Well,
sorry, but I think
going.
we're actually
No, no.
using this thing. Oh, I'm sorry, but we are actually reading from a legacy map. And like I was saying, it is because of our implementation. That is why we are having need to add this plus 1. Sorry, ma, please. If we don't want to add this plus 1,
This
right?
is
We need to do
implementation.
this current ID addition
To be
after
after, yes.
not before. So if we don't want that plus 1, we'll just move this current ID addition downward. So we'll be using the ID as the ID of the to do. Then after that, we can update
Yeah,
it.
yes.
Are we okay now?
You have to add plus 1 to the count.
We need the plus 1. We need the plus 1 now.
Also, one last thing, you need to make index mutable.
Thank you.
Yes.
Yeah.
And we even need to change the data type because I discovered you cannot do greater than and less than with 252.
Data type of what?
The index, index and count.
Okay, we did not set data type, right?
Yes.
Data type of count. Is that what you are saying? Hello? Hello?
Data type of count and index. Because
Count is
if,
you in 8.
okay. So we need to change index. We need to set it to in eight. We'll not be able to do it.
Are we okay now?
Yes.
Why did I get error here? Okay, so I just want to try to test this. Just these two. To add to do and to get to do.
But the append you called, actually adds to.
Actually, what?
I, I think it actually adds to an array. Just the way we have
Yes,
push, they append.
yes, yes. That's what it does. So, what are you trying to say?
I thought we are actually getting instead of inserting.
Yes, now we are getting, but to get is a mapping. So we have to push the items into an array so that we can easily read the array.
Okay, 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 okay,
Yes.
okay,
So we'll now return the array to be able to read what we push to the mapping.
okay, okay.
Yeah. If somebody raise their hand. Okay, so okay, let's try this out. Um, we hope everything is okay. So once you've written your code, the next thing to do is to build. Okay, now this is the main problem. Version conflicts. So we used our smart contract version 1 cannot use Starknet version 2.2.0 because it requires Starknet version 2.6.3. So I need to update my scab in case you guys come against this error. You need to update your scab. So I think we have scab here. Okay, okay, okay. Let me use this 2.6.3. When is your next class?
Next week Wednesday. That's Wednesday.
Next week Wednesday. And when is the class supposed to end? I can't hear you.
7.
Oh, so I'm eating into your time.
No worries, no worries.
Thank you. Okay, so it's taking some time to check into. Okay, so let's check. Oops. Um, okay, please work. Okay, so let's correct our errors. So our first A. Okay, so for the return type of implementation function I to do list dispatcher get to do's is incompatible with I to do list dispatcher trait get to do's. Expected an array actual
Yeah, you
because
can
array
define the type of data the array is will contain.
this array.
Yeah, using the arrow.
So what should it contain? To do Event 8 to return to do's. Is returning to do's. Is returning to do. Okay, so next
The interface.
type what?
Also at the interface.
Oh, type annotation. Next it. Type annotation needed. Array. Okay, next array. 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 Okay, so I think array is the culprit. Then what is this? Okay, so let's see if this works. If it doesn't, we have to go and check how to call an array. Okay, so missing semicolon, line 51. Am I supposed to? Okay. And to do's dot append, ref argument must be a mutable variable. This must be a mutable variable, the array. And what else? Okay, so let's see. Okay, variable not dropped. Oh, do you need it to be dropped? Oh, guys, let's check how to call an array properly. I'm trying to see how to return an array. If anyone has seen it, please let me know, so don't waste so much time. Are you guys with me? Okay.
Yes, yes. Yes.
I've just sent a link to Cairo by example. So
Okay.
that's all.
Okay, so array traits. And this array traits new. Well, we are on track. We are actually on track with this.
I think the reason why it's saying that dropped something is because that drop
we
attribute
added
was,
what?
I think the drop attribute was added to the traits. That's why you need to import the traits to use that like array as a return type.
What do you mean import the traits?
Sorry, that use array, then
This
array. Yes, some this supposed to work.
yeah. So, okay, so it's not an array. So it will be an array of different to do. Why is this a problem?
Sorry, please, can you go to your traits? First one. You are not, you should use to do, like use to do the struct, because it does not know the struct inside to do module. So like the line 7 now, this to do inside your array, it does not know it. This your traits does
Oh
not have
yeah, thank you. Yes. Wow. And I pointed that out. How did I forget? Okay. Let's see. Hey, okay. We did it. Thank you so much. So the first error was my stabbed version. And the second error was because we're calling a function inside this mode, a function inside this module. And so we had to reference it this way. So yeah, guys, so hope you understand what I just did, what we just did.
Yes, yes.
Okay, so next is um, I would have loved to test this, but our time is really, really up. So maybe in our next class, if I have a class with you guys, someone else will be taking you guys on testing. So I think I should just complete this. There's no quick way to actually test it. We have to write another testing file, like another contract for testing, unlike normal Cairo programs. So I'm sorry. Let's quickly update and then get. So to get to do won't be as tough as this because it's already taking the index. So to implement this, all we have to do is self dot to do list dot read, and we'll pass the index, and that's all. Do we agree?
Yeah.
Okay, thank you. The ladies, are you still on the call? Yeah, very.
Yes.
Oh, are you following or
Yeah.
did you get confused? Um,
Yeah, I got confused along the way, but I'll find myself.
very sorry about that. That's the problem with a Cairo. Benjamin, you've not been talking. David. Um,
You know,
okay, yeah, okay, true. Sorry. So you're following, right? Everything is going well. David, how is it going? Oh, great, nice. Um, who was with us from the beginning? That Aji. Is Aji still with us? Aji, are you still on the call?
Yeah. He's still on the call, but his laptop's mic got spoiled.
Wow. Abel Adefokun. Um, Aji is enough. Abel Nicholas. Yes, Daniel Joseph.
Yes, I'm still on transit.
Wow. Okay. Nicholas. All of you are getting it. So it's only Vicky that don't get it. You are going to write assessment. Oh, you are going to do a test. No. If people don't get it, better to say you didn't get it though. There's an assessment like immediately after this class. Okay. Okay. All right, it's fine, Abel. But if people said you got it, why are you shocked? So so the assessment, because I'm really sorry, I'm entering into your time. So your assessment will be to implement the last function updates. So what do you guys need? Should I push this code to a repo and share the link? in the Telegram chat.
Yeah, you can put it in
Okay,
a GitHub gist. Yeah.
in the gist. Okay, cool. So you guys should implement the last function updates, so you don't do everything from scratch again, and that will be your assessment. And I don't know. Um, we were meant to do more than this. We're also supposed to do contract interaction, but I hope probably if you guys have time again, we can meet before Wednesday. If not, we hope the class on Wednesday would handle it. But
We
if
have
you
time.
have
We
time,
have
you
time.
people should
We have
just
time.
reach out to me and Sam. So we just fix another class. So we tidy up this project we just built. We deploy it because we cannot. I don't want to write test for it because you'll be doing testing in another class. So we'll deploy it and try it on chain to see if it works as expected. And if not, we'll brainstorm on what we did wrong, why it didn't work, and correct our mistakes. Hope that is fine.
Yes,
Then
ma'am.
we'll do contract interaction. So we'll build another contract and try to interact with this contract from that one in the next class. After making sure that this contract is perfect, the to-do list is perfect. So I would just move this to gist, send the link to Telegram. You guys should work on it by, you don't need so much time. It's very easy. By 9 a.m., 9 p.m. today, you should be ready. Submit your gist with your update to do function in it. And Sam will track it from the list of those that have submitted there. Then you guys should talk together and fix a date and let me know. Let Sam also know. So we fix a class and round off this particular project. I don't want to rush you guys because I really want you to understand what is going on behind the scene, how everything is computing. So immediately you finish this program, you start writing quality code, not just any Cairo code, real quality code that is production ready. That is my aim. That is my own aim. So I wish you guys the best. So I'll be posting on Gist. Have a nice evening, everyone. And I'll be hoping to hear your response for the next class. Bye, everybody.
Bye bye.
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 Bye. Thank you.
Yeah.